Okay, so here's my Spiral notebook, what we're going to have updated. I should have my table of contents. In Chapter 2, I'm going to talk about my real numbers, perfect squares, and properties. In Chapter 3, I'm taking notes over solutions. I should say proportions and cross products. And in Chapter 4, we talked about quadrants and coordinates, intercepts, slope, direct variation, and linear function. If you have some other things in there, that is totally okay, but this is what I'm going to have in mind that should help you for now. You should have had with our real numbers, natural whole integers. We did the whole thing explaining them. Our facts and characteristics, examples, non-examples, and we did that for each one of them. We talked about the real number system, where they kind of go. Over here, this was with perfect squares. Write that in there. With perfect squares. Remember, the square root of like 36 is 6, because 6 times 6 is 36. Square root of 144 was 12, because 12 times 12 is 144. And if you need to pause this page at all to copy any notes, you're more than welcome to. But this is how we found the square root of irrational numbers. We listed perfect squares before and after. We identified the square root of the perfect squares. We created a number line. Where would square root of 34 land to the nearest tenth? And kind of like a guess and check. So when we said the square root of 34, the perfect squares were square root of 25, square root of 36. We identified the perfect squares, so 5, 6. That would become my number line. So between 5 and 6, I said square root of 34 is closer to square root of 36. So I guessed maybe 5.9. I did 5.9 times 5.9 because I'm squaring it. And I found that 5.9 squared is 34.81. So the square root of 34.81 is 5.9. Okay, 34.81 is really close to 34. But I went down 1/10. And I have 5.8 times 5.8 was 33.64. Okay, so the square root of 33.64. I now have the squares between square root of 34. Square root of 33.64 is too small. Square root of 34.81 is too big. And we say which is closer to the square root of 34. 33.64 or square root of 34.81. And the square root of 33.64 is closer to square root of 34. So we say the square root of 34 equals 5.8 to the nearest tenth. On this page, we should have had what the commutative, property, associative, identity, inverse, distributive, and zero product is. We have our examples in there. If you need any of these, please see me and I will give them to you. Or you can pause this. I guess I'll flip it open real quick. Inverse, distributive, and zero property. You can remember, you can pause this video at any time to see. Then I made my little foldable for Chapter 3. We talked about solutions. Whether an equation has one, no solution, infinite. Remember, one solution. Oops, looks like I need to cut mine just a little farther. Would have been one solution. Remember, when we get to the variable equals a term. Biggest mistake I remember us making was, remember, our variable can equal 0. So if you get x equals 0, that's one solution. No solution is when we get a false statement, such as 0 equals -3. Infinite solution is when we get a true statement. 4p equals 4p, we divided by 4, we got p equals p. If I would have subtracted 4p from each side, we would have got 0 equals 0. True statements anytime that statement's true. 7 equals 7, 13 equals 13. If we find that in our equation, we can put any value in for the variable. Should have this page writing a percent as fraction. There's our notes. Using a proportion to solve a percent problem. Make sure we understand this in our examples. And percent of change. I know we need to know this. Percent of change, remember the difference, which is always a positive number. We want the absolute value over the original amount equals a percent over 100. And our examples that you could have done. In chapter 4, these are some that you probably don't have down yet. The important information for quadrant and coordinates. Remember coordinates 1, 2, 3, 4. This is our y-axis, our x-axis, and our origins at 0, 0. Coordinates are listed x first, then y. So it's like the run, then rising. If I looked for A, I would have said like 1, 2. B, negative 2, 1. C, negative 1, negative 3. D would have been 2, negative 1. All the coordinates in quadrant 1 are positive, positive. In quadrant 2, negative, positive. Quadrant 3, negative, negative. And in D, positive, negative. We talked about intercepts. We should have glued these in. Remember, if you need to pause and copy this down, you can. But to find the x-intercept, we go ahead and we set y to 0. So if we had the equation y equals 2x plus 4, I make my y 0, like I did here, set y to 0. So automatically in my coordinates, I have a 0. And then I solve the equation. 0 equals 2x plus 4. We solve all the way down till 2 equals x. So my coordinate is 2, 0. My graph would have crossed the line at 2, 0. For the y-intercept, it's just backwards. I set my x to 0. Same equation, so I had y equals 2x plus 4. I rewrote it as y equals 2 times 0 plus 4. And we end up with y equals 4. Slope. We went ahead and described slope on our OneNote. I put in here for the reminder. Remember, slope is represented by m, and it is the rise over the run. We can look at a graph like this, and I could pick two easy points I can pick out and do my rise. Like this one went up 2, so my rise is 2, and it went over 3 points, so let's say 3. My slope is 2/3. We also find it if they list coordinates by your y2 minus y1 all over x2 minus x1. So find the slope of negative 4, positive 2, and 2, 6. I did my work here. I did 6 minus 2 all over 2 minus negative 4, which would give me 4 6. Remember, negative, or subtracting a negative is like adding a positive. And then I simplified down to 2/3. Our 4 types of slopes. Positive, when you read it left to right, it's moving up and to the right. Negative, going from the right, it's moving down. A horizontal slope is what we call 0. It's a slope that just is straight left and right. The slope is equal to 0. It's a horizontal. And then a vertical slope is what we call undefined. That's when our denominator equals 0, we cannot have it. So we say there is no slope, it is undefined. Direct variation. Turn this way for you if you need to copy it. We took these notes in OneNote. Remember, direct variation, y equals like 5x. Usually we're using the letter A for direct variation, and A represents the constant of variation. So I think on your test they'll say, what is the constant of variation? Well, you're solving where y equals 5x, so the constant of variation is just 5. Remember, direct variations, there is no y-intercept. They pass through the origin. They can be positive or negative as long as it cuts through the origin. Non-example because this is in slope-intercept form, and that positive 5 means there's an intercept at 5. So that would not work. And our last piece of note, linear function. Remember, linear functions are the ones that when we graph their straight line, they follow our slope-intercept form of y equals mx plus b. Remember, m is our slope, b is our y-intercept. If they told us to evaluate the function when x is negative 2, this says the function of x equals 12x plus 1. I put the negative 2 in. We get a final answer of negative 23. So the function of x is negative 23. The other thing they're going to talk about is the parent function. The function of x equals x. Parent functions pass through 0, 0, and they have a 1 slope. Just like this. It's positive. It's rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Okay, if you have any questions, you can see mine, and I'll show you where they are in OneNote.